This is example 5. It's very similar to example 4. Once again, figuring out the empirical formula of a compound by doing a combustion reaction or an empirical gravimetric analysis. So this time we've got 87 grams of chromium reacting in oxygen or burning in oxygen to form 127.15 grams of a compound. And once again, we've got to calculate the mass of oxygen, the moles of chromium, the moles of oxygen, and therefore the ratio of chromium to oxygen atoms, and therefore the empirical formula. So step 1. Obviously, the compound weighs more than the original chromium because oxygen's bonded with it to form the compound, and the difference in mass is the mass of oxygen that actually reacted. So we can say the mass of oxygen that reacted is the mass of the chromium oxide, which is the product, take away the mass of the original chromium. That's going to be 127.15, take away 87. I trust you can put that in your calculators, and that'll give you an answer of 40.15 grams. So that's part A. Part B, we've got to find the moles of chromium we had that reacted. So how many moles of chromium are in this compound? Well, once again, number of moles equals mass of molar mass. Do we know the moles of chromium, the mass of chromium, the molar mass of chromium? Well, we don't know the moles of chromium, so we're going to try and find out. We do know from the question that we have 87 grams of chromium, and from the periodic table, the molar mass of chromium is 52 grams per mole. So now we can substitute. Number of moles of chromium is 87 grams divided by 52 grams per mole, which means we've got 1.673 moles of chromium in this particular compound we've made. And once again, we don't round off. Once again, I'm going to store that in my calculator as A. On to oxygen. We're going to find the moles of oxygen in the compound, and just like in example 4, once the oxygen is in the compound, it's not in the form of O2 anymore. We want to find exactly how many oxygen atoms, not oxygen molecules, how many oxygen atoms are in this compound. So we've got to do the calculation for that. So number of moles equals mass of a molar mass. Once again, how many moles of oxygen atoms do we have? What's the mass of oxygen we've got? And what's the molar mass of oxygen atoms? Once again, we don't know the moles of oxygen. We're trying to find that. We know there's 40.15 grams of oxygen in this compound from what we calculated in part A, and we know the molar mass in the periodic table is 16 grams per mole. So substituting, we've got number of moles of oxygen equals 40.15 divided by 16, which gives me 2.509. Once again, I'm not rounding off, I'm just putting that number in my calculator as B. So now we know the moles of chromium, and we know the moles of oxygen in this particular compound that we've made. Which leads us on to the empirical formula. Once again, the empirical formula is just the ratio of atoms. How many chromium atoms for how many oxygen atoms? Once again, because moles is just a counting number of atoms, therefore if we can find the mole ratio, moles of chromium to moles of oxygen, we know the atom ratio, and therefore we know the empirical formula. So what's that ratio going to be? It's going to be that moles of chromium, which is a 1.673, which we had over here, divided, or the ratio to the moles of oxygen, 2.509, which was A to B in my calculator. And just like before, we can divide by the smallest number to find that ratio. But divided by the smallest number, which is in this case 1.673, which in this case I'm actually going to be doing something like A divided by A, which is 1 in my calculator, and A divided by B in my calculator. Sorry, in this case, B divided by A in my calculator to give me these numbers. When I do that, I get the ratio of 1 to 1.5. And that's not what we normally see in chemical formula. We don't see a formula like chromium 1, oxygen 1.5. We know they've got to be simple whole number ratios. So when you get a situation like this where you've got 1 as to a fraction, what you've got to do is somehow convert that to a whole number ratio. And that can be done sometimes with the fraction button in your calculator, but be careful. If you get a funny number with numbers bigger than 7, that's not right. Usually numbers in chemical formula have no more than 7, usually atoms in there. So if you're getting big funny numbers, do a double check. In this case though, because we've got a fraction of a half in our ratio, a simple way to get rid of that is just to double both numbers. So the ratio 1 to 1.5 is the same as the ratio is 2 to 3. And that tells us there's 2 chromium atoms, or 2 chromium moles, for every 3 chromium atoms, or every 3 chromium, start that again. There are 2 chromium atoms for every 3 oxygen atoms, or 2 chromium moles for every 3 oxygen moles, and therefore the simple empirical formula for this compound is Cr2O3. And once again, we figured out the formula, the empirical formula of a compound, by looking at the masses in that particular compound.